I've made 10 quick videos about the Collatz conjecture, the 3x+1 problem, and now I want to do one more just to seal the deal. So what you're looking at here in the graph is a well-known sequence for 3x+1. It's input 27 and it takes 114 steps to reach 1. So what does this graph have to do with this table? A lot, because we only need to look at the very first column, and that is where n equals 1. And what we have is an input-output table for the Collatz sequence. So just to quickly look at a few numbers, 27 goes to 41, 41 goes to 31, 31 goes to 47. So I think you can just see from that actually the sequence is pretty facile and only looks more complicated than it really is because of the even numbers, which we've already discussed. We don't need them. Now I'm going to show you why all n's greater than 1 produce complex sequences. And I'm just going to go into an Excel app, a working one, and we're going to just put in another number here. We could put in any number we wanted, any odd number we wanted. We could just start with 3, and then all you get out is 3. You put in 5, and we get a complex sequence of a few numbers, 1, 2, 3, 1, 2, 3, 4, and so on. Go to 11, see what we get for that. We get quite a complex sequence. And then we're going to go to 17 because that's the number I'm prepared to deal with at this moment. So 17, this is the complex sequence, and we can see that the loop is this long. So let me just copy these numbers. And now we're going to go back to this table, and I'm going to move this out of the way. And first we're going to consider that 17 and 17, so there is an input 17 that results in an output 17. Now, we could look at the numbers, the input numbers here, as they relate to the output numbers here. That will take too long. So what I'm going to do is go straight down here and show you this is the input-output sequence for 17. 17 to 17 is 0. And north and south of 0, we have two inverse pairs which cancel each other out. These operations, input-output operations. So 11 to 25 is 14. 13 to minus 1 is minus 14 in terms of an operation. 21 to 1 is minus 20 in terms of an operation. 23 to 43 is 20. So these operations cancel each other out. Now, let's quickly paste those numbers I stole from the other spreadsheet. If they're still there. Okay, so look up at the top here. 11, 25, 23, 43. 11, 25, 23, 43. A complex loop is always associated with inverse pairs, two inverse pairs of operations. Now, let's look at 1. 3x+1. It only has one inverse pair. The other one is somewhere in the universe on the other side of 0. This is why you do not have complex loops for 3x+1.